All right, so the lab that we're going to be doing today, we're just going to be investigating the relationship between normal force and the force of friction. Okay? Because those are the two things that we're going to be actively changing and measuring. Okay, so if we're looking at identifying our variables here, here's how the procedure is going to work so that you can figure out which one's responding, which one's manipulated, and which ones are controlled. Okay? Each time we do this lab, okay, we're going to have one of these incredibly high-tech friction sleds. Okay? These were, carefully designed and constructed by myself and Mr. Dickey using the handyman's secret weapon, duct tape. Okay? You guys all know who Red Green is? It's a generation gap thing. Okay, like one of the coolest Canadians ever, Red Green. Okay, and his thing was he was the person who said that duct tape is the handyman's secret weapon. He also said that if the women don't find you handsome, they should at least find you handy. Okay, so anyway, he built all kinds of stuff out of duct tape. So we took some duct tape and we just put these strings on here so that we can pull these along the floor. So here's what's going to happen in the procedure. Okay, we're going to start out with the sled empty. Okay, so no masses in the sled. Don't use this sled. It's broken. Okay, you can put it back. Yeah, that would be glue more than tape, but okay. So you're going to start out, that'll be your first trial, okay? Just the sled. Incidentally, the mass of just the sled, I don't know why I have cart up here, but just the sled is 0.254 kilograms. Okay? So that'll be your first trial. In your next trial, you're going to add mass to it. Probably the two smallest masses, because if you just add the first mass, it doesn't make enough of a difference. Okay? So your second trial, you're going to add the smallest two masses. Now when I do that, I'm changing the normal force. Okay? And in each trial, I'm going to add more mass. So each successive trial, okay, the normal force will get bigger and bigger. So this is how many, think about how many trials you're going to have. You're going to have one trial empty, one trial with the first two masses, okay? One trial with the first three masses, one trial 4, 5, 6, okay? Keep knocking that piece off. So that's what's going to happen there. Now each time, we're going to just give it a pull. When we give it a pull, we're going to be measuring the force of static friction acting on the cart. And here's how we're going to do that. Okay? Each time that we do this, okay, we're going to have one of these force sensors attached to the string. Okay? And what you do with the force sensors, they got these little finger holes on them. Okay? So you set the force sensor down on the floor. That way it's level with the sled, because you don't, after the questions we did yesterday, you don't want to be pulling at an angle. Okay? You don't want to be pulling down into the floor either, because that'll change the normal force. So that angle thing is kind of important that it stays the same for all the trials. Okay, good, everybody got that one. Okay, so what you're going to do, and you have to do this very, very gently, okay? You're going to just pull gently, gently, stronger and stronger and stronger until the sled moves. Then stop. Okay, so it's going to be a little bit tricky, and you're going to do this on the floor. Don't do it on the desktop because the desktops are too slippery. Okay, so now this works a little bit differently. This is the old ones before we got the new carts. This is just the Bluetooth transmitter. No, it's huge. It's old technology. Okay, that's the Bluetooth transmitter. That's what you're going to connect to. Okay, and they all have an ID number on them as well, just like the carts do. Okay, so that's what you're going to connect to in the SparkView app. Okay, now when I'm doing this lab, okay, I'm just going to pull with the finger holes until the sled starts to move. That's it. Then I change the mass, and then I keep going and I keep going. All you're going to look for in your data is the largest force, because your data is going to go like this. It's going to go up, 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 and then it's just going to drop. Okay, that point where it drops is where the sled started to move. So that maximum force is the amount of force you needed to overcome static friction. Exactly. So that is the maximum amount of static frictional force for that trial. Okay, so whatever the maximum force is that you've got, okay, that is your maximum force for that. That's your force of friction for that trial. Does everyone follow me there? So you'll have the normal force because you'll know the mass and you'll multiply it by gravity, okay, and then you'll be able to get the maximum force. So you actually don't have to get anything other than that from each trial. It's just look at the numbers, there's my maximum force, pull that number. Okay, you are going to build a graph, but it's only going to be using your normal forces and your maximum static frictional force for each trial. Okay, so you don't actually have to build a graph with the raw data. You're just going through that trial to find the largest number. Okay, everybody with me there? All right, now for our hypothesis, okay, the hypothesis needs to work this way. The if part needs to talk about the relationship between normal force and the force of friction. Okay, so if there is this kind of relationship between, or just talk about how they're related, and one goes up, the other goes up, or one goes down, the other goes up, or whatever you think it is, okay, you talk about that in the if part. All right, the and part describes the experiment, same as always. In the then part, I want you to tell me how you're going to calculate the coefficient of friction from your normal force versus force of friction graph. Okay, you're calculating the coefficient of friction for the entire lab, not trial by trial. I mean, it should be the same for every trial, but okay, we're not calculating it for every trial. We're building a graph and we're calculating it once using the graph. Okay, I cannot stress that enough because whenever I do this lab, inevitably I get people who hand in their lab report and they have done 6 separate calculations of mu and say, here you go, Mr. Coder, I did it. And it's not how I want you to do it. I know you can manipulate this formula to solve for mu. I don't want you to do it that way. I want you to get mu from your graph. Okay? You are going to have a graph, okay, of normal force. Okay? This isn't the graph. You're going to have a graph of normal force versus force of friction, okay? And it should go like this, right? It should go like that anyway, okay? If it doesn't, you did something wrong. I want you to calculate mu from that graph, okay? That's what I want you to calculate. You guys can figure that out. It's not that hard. It's one calculation, okay? Just one. Okay? Think about that formula and how it works. Okay, now when you're doing your actual experiment, okay, you're going to get your data looking like this, and you're just going to go through it and go, okay, so for trial 1, my maximum pulling force was 1.14 newtons. For trial 2, it was 1.37. For trial 3, it was 1.43, 1.5, whatever your numbers end up being. You're just going through your data and looking for the biggest number. Okay, everybody with me there? And so what's going to happen is, as I said, you're going to get your force is going to go up, 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 up for each trial, and then it's just going to fall off. Okay, that'll be your maximum number right there. So when you're looking at it on the screen when you're doing the lab, okay, you'll see that happen. Okay, so we've talked about the procedure already. Okay, then you're going to have to fill in. So take these numbers, and you're going to fill in this chart, okay, which is in your lab report. All right, so you're going to have your mass, okay, your normal force, which you calculate by taking mass and multiplying by gravity, by 9.81. And then this is the number that you're getting from here. Okay, so your maximum static frictional force is the one you're getting as the maximum force for each trial. Okay, so you just have to fill in that chart for the analysis, build your graph, and get mu from the graph. That's it. That's your whole analysis. Filling in that chart, building a graph, and calculating mu from the graph. That's it. Okay. Then in conclusion, copy paste your hypothesis, tell me whether it worked or not, why you can accept it, okay, and any sources of error, okay, that you might think of. They might have to do with how you pull that sled. Okay. Questions on that? All right. I am hoping that this is not going to be a huge amount of homework for anybody, that you're going to get the vast majority of this whole lab report essentially done in class today. Okay? Because the lab procedure does not take very long. You pull the cart 6 times and you're done. Okay? It should be pretty quick. All right? If anybody has trouble, let me know, okay? And I'll help you out. So, You need one Bluetooth transmitter and one force sensor and one friction sled, okay, for each group.